Dear students, so in previous class we were discussing a semi-linear differential equation and how to solve the semi-linear equations. In this class, now let us discuss about quasi-linear equation. So what is a quasi-linear equation? Consider a quasi-linear equation Pxyz zx plus Qxyz zy equals Rxyz. Then, its solution z equals zx, or its solution defines an integral surface z equals zxy. Then, this integral surface, or it defines an integral, the solution z equals zxy defines an integral surface z equals zxy, or the solution z defines an integral surface z equals zxy in xyz space. Now the normal to this surface having direction ratios, normal to this surface having direction ratios zx, zy, triple h, zx, zy minus 1. Therefore, the given equation Pxyz zx plus Qxyz zy equals Rxyz, which satisfies the condition that the integral surface is such that at each point the line with the direction ratios triple h, p, q, r is tangent to the surface at this point. So the solution z defines an integral surface z equals zxy in xyz space. In previous case or in semi-linear equation, the solution z equals zxy defines in an xy plane. But here z equals zxy, the integral surface z equals zxy defines in xyz space. So the space has a direction ratios. So the line has the normal to the space. The normal to this integral surface has a direction ratios triple h zx zy minus 1. Okay. Then, so consider this quasi-linear equation. Then here P, Q and R, P, Q and R has continuous partial derivatives with respect to x, y and z, and they do not vanish simultaneously. Means dp by dx, dp del p by del x, del p by del y, del p by del z. Similarly del q by del x, del q by del y, del q by del z. Similarly this one, and they have continuous partial derivative, but they do not vanish simultaneously. So, moreover, a result states that the quasi-linear differential equation has a solution only when it is dy naught by ds into p minus dx naught by ds into q, which is strictly differs from 0. Whenever dy naught by ds into p minus dx naught by ds into q differs from 0, then we can conclude that the quasi-linear equation has a unique solution, where the initial curve, that is z equals z naught s, that z equals z naught s, be prescribed along the initial curve, this gamma naught, here x equals x naught s, y equals y naught s. Okay, then x naught, y naught, z naught being continuously differentiable functions with s ranges from a to b. Therefore, this quasi-linear differential equation has, that's a crucial point, has solution only when dy naught by ds into p minus dx naught by ds into q strictly differs from 0. If it happens, then its solution exists. Okay. Then now let us consider how to solve the quasi-linear differential equation, partial differential equation, quasi-linear equation. How to solve this one? So consider a quasi-linear equation z into zx plus zy equals 1. zx plus zy equals 1 with the initial conditions x equals s, y equals s and z equals s by 2, where s ranges from 0 to 1. S ranges from 0 to 1. How to solve this one? So in order to solve this quasi-linear equation, first we have to compare this equation with the standard quasi-linear. So by comparing, what do you get? Here P equals, what is P? P equals z and Q equals 1 as well as R equals 1. When you compare with the standard quasi-linear, we have P equals z, Q equals 1 and R equals 1. So we know that the quasi-linear equation has a solution only when dy naught by ds into P minus dx naught by ds into Q is differs from 0. So what about y naught here? Here y naught is s, x naught is s. X naught means when t equals 0, corresponding x value is s. So y naught is s. So what is dy naught by ds? That is 1. So here 1 into p means it is h. So it is that gives dy naught by ds, that is 1 into p minus dx naught by s. X naught is again s. So dx naught by s is also 1. So p minus q. What is p? P equals h minus q is 1. But what is h? Z is s by 2. So here s by 2 minus 1, which is differs from 0. Why? Because s ranges from 0 to 1. So s by 2 strictly less than 1. Therefore s by 2 minus 1 is strictly differs from 0. Thus the given quasi-linear equation has a solution. Agree? Now how to solve this one? So we know that dx by dt equals p, dy by dt equals q, and dz by dt equals r. So in previous class, this have an explanation. So dx by dt is p. What is dx by dt? What is p here? P equals h. That means dx by dt equals p, dy by dt equals q, and dz by dt equals r. Dx by dt is p means h. What is dy by dt? Q means 1. And what is dz by dt? Dz by dt is r is again 1. So consider dy by dt is 1. Dy by dt equals 1 means dy equals dt. So on integration, it is y equals t plus c1. Okay. So by the initial argument means x naught equals s. X naught equals s means if t equals 0, corresponding x value is s. Okay. So when t equals 0, similarly y naught. When t equals 0, what happens? Y naught equals 0 plus c1. But what is y naught? Y naught is s. So that means s equals c1. So from here, y equals t plus c1 means y equals t plus s. Okay, y equals t plus s. Again, dz by dt is 1. dz by dt is 1 means dz by dt equals 1. So that means z equals t plus c2 on integration. Again, by the initial conditions, when t equals 0, what is z naught? That is s by 2. So it is s by 2 equals t plus c2. So 0 plus c2. So c2 equals s by 2. So that means yes, c2 equals s by 2. So what is z? Z equals t plus s by 2. Okay, z equals t plus s by 2. Now again, what is dx by dt? Dx by dt equals h. Dx by dt equals h implies dx by dt equals, what is h? T plus s by 2. Dx by dt equals z means dx by dt, that is dx equals z dt. That means dx by dt equals t plus s by 2 means dx equals t plus s by 2 into dt. So on integration, what you get? X equals t dt means t square by 2 plus s t by 2. So we obtained the different values of x, y and z. So what is y? Y equals t plus s. So listen here, y equals t plus s, comma z equals t plus s by 2, and x equals, what is x? And x equals t square by 2 plus st by 2. Then you can solve this t and s, solving for t and s in terms of x and y. So how to solve? Solving for s and t and s in terms of x and y. So listen, that means what is x? X equals t, it is t by 2 into t plus s. Okay, so that means that equals t by 2 into, what is t plus s? That is y. So x equals t by 2 into y. Okay. Yes, what is x here? X equals, sorry, that's on C3. Sorry, there's a change into plus C3. Okay. So here we have these values. Y equals t plus s, z equals t plus s by 2, and x equals t square by 2 plus st by 2 plus C3. Now, by the initial arguments, by the initial condition, what is x naught? That is s. So when t equals 0, s equals C3. Okay, t equals 0, the first two terms are vanishing. So what is x? So this x equals C3 equals s. So it is t square by 2 plus st by 2 plus s itself. Agree? So that means you can solve this t and solving for t and s in terms of x and y. That means x equals t by 2 into t plus s plus s. That means x equals t by 2 into, what is t plus s? It is y plus s. Okay, so x equals t by 2 into y plus s. But what is t? From here, t equals y minus s. So that means x equals y minus s by 2 into y plus s. On solving, then we get what is s there. S is in terms of x and y. So here s equals y square minus 2x divided by y minus 2. On solving here. Okay. So s equals y square minus 2x by y minus 2. But what is y? Y equals t plus s. Again y equals t plus s. So that implies t equals y minus s. So that means t equals y minus, what is s? S is in terms of x and y square minus 2x by y minus 2. So on solving, you have it is 2 into x minus y divided by y minus 2. Enough. So here in starting we say that the solution of the quasi-linear differential equation is nothing but z that defines an integral surface z equals zxy. So what is the solution? It is, we have z equals t plus s by 2. What is t? Z equals t plus s by 2. That means z equals t means what is t? It is 2 into x minus y by y minus 2 plus s by 2. What is s? It is y square minus 2x by 2 into y minus 2. So finally we have, then on solving, on reducing this one, so we have what is y. You can solve this one, then you obtain what is actually y here. That is y equals, by taking LCM, it is 4 into x minus y plus y square minus 2x all divided by 2 into y minus 2. Okay, so that implies z equals 2 into x minus 2y plus y square all divided by 2 into y minus 2. That is z equals zxy. So this is the required solution, means that is the required integral surface. Okay, so here now consider the line which has the direction ratios triplet zx, zy minus 1, which is always normal to this integral surface z equals zxy, that is 2 into x minus 2y plus y square by 2 into y minus 2. Agreed? So this is the required solution. This is the method to find out the solution of a quasi-linear equation. Agreed? Now, consider another one. Find the solution of or solve the Cauchy problem. Solve the Cauchy problem. 2zx. Cauchy problem. That is 2 into zx plus zy equals h. Using the initial condition, x naught equals s, here x equals s, or it is passing through s, s square and s, where s ranges from 1 to 2. Or x naught equals s, that is the initial condition. With the initial condition x naught equals s, y naught equals s square, and z naught equals also s, where s ranges from where to where? S ranges from 1 to 2. How to solve this one? So for solving this Cauchy problem, you have to compare it with the Cauchy differential equation. So on comparing, what is p? P equals 2, q equals 1, and r equals h. Okay. Yes. So first we will check that whether it has a solution. So for what about the condition dy naught ds into p minus dx naught by ds into q. Consider this one. So equals, what is dy naught? Y naught is 2s. So dy naught by ds, that is 2s into p means 2. So it is 4s minus dx naught by ds, that is 1 into q 1. So since s ranges from 0 to, since s ranges from 1 to 2, so it is always differs from 0. Therefore the quasi-linear differential equation, the quasi-linear equation has a solution. The solution is admissible. Okay. Now consider we have dx by dt. Dx by dt equals p. Dx by dt equals p. Dy by dt. Dy by dt equals q. Sorry, it is not zy, it is y into zy. Sorry, the question is dy by dt equals q. So what is q? Q equals y, and dz by dt. Dz by dt equals r, means which is such. Okay. Now dx by dt equals q means what is x here? X equals 2 dt. So 2t on integration, it is 2t plus c1. So by the initial condition, when t equals 0, x naught equals s. So this gives c1 equals s. Okay. When t equals 0, we have x naught equals s. So this gives s equals c1. So that means x equals 2t plus s. Agreed? Dy by dt is y. Second one. Dy by dt is y. That means dy by y equals dt. So on integration, it is log y equals t plus c2. Okay, log y equals t plus c2. So when t equals 0, by the initial condition, when t equals 0, what is y naught? Y naught equals s square. So this gives log s square equals c2. Log s square equals c2. Log s square means, or it is yes, log s square equals c2. So from here, log y equals, that implies log y equals t plus log c2. So c2 means log s square. Log s square means actually it is 2 log s. Okay. So that means log y minus log s square. So log a minus log b, log a by b, that is log y by s square equals t. That means y by s square equals e power t. Y by s square equals e power t, or y equals, here y equals s square into e power t. This is y. Okay. Again, what is such dz by dt? dz by dt. Similarly, dz by dt equals such means dz by z equals dt. dz by dt equals dt. That means again on integration log z equals t plus c3. So by the initial condition when t equals 0, what is z naught? Z naught is again yes. So it is log s equals c3. So that implies log z equals t plus c3. So it is log z equals t plus log s. That means z by s equals t, or that means z equals s into t. S into e power t. So here x equals 2t plus s, y equals s square et, and z equals s into e power t. Okay. Now the next step is you can solve for this s and t in terms of x and y. Okay, that's our next simplification. So x equals 2t plus s, y equals this one, and what about y by z there? S square e power t, s e power t. So y by z equals simply s itself. Okay, y by z equals s. Moreover, z equals s into e power t. Z equals s into e power t. But what is s? Y by z. That means z equals y by z into e power t. That means z square equals y into e power t. Z square equals y into e power t. So z square equals y into e power t means z square by y. That is e power t. Okay. So from here what is t? T equals log z square by y. T equals log z square by y. But what is x? But x equals 2t plus s. That implies x equals 2 into what is t? Log z square by y plus s. So what is s? So s means it is y by z. Okay, from here. So x equals 2 log z square by y plus y by z. That means x minus y by z equals 2 log z square by y. Okay. So on simplification we have x minus y by z. X minus y by z means on taking LCM xz minus y by z equals 2 log z square by y, or on taking here, on putting 2 to the left side, it is log z square by y. So what is z square by y? It is e power of xz